name is Hannah Charnock, and I'm currently going into the 4th year of my PhD at Brock University under the supervision of Dr. Belinda Kemp and Dr. Gary Pickering. My research takes place on site at the Cool Climate Enology and Viticulture Institute here in Niagara, where I research the chemistry underlying sparkling wine aging. Particularly, I look at a reaction called the Maillard reaction, which is implicated in the formation of desirable bready, roasted, caramel, and toasted aromas. However, this reaction has been primarily studied in heated products, where heat drives the formation of these compounds. Some studies have shown that these compounds also exist in aged sparkling wine, so my research is looking at how these reactions take place under the low temperature and low pH conditions over an extended storage period. This year, my experiments are going to look at model conditions to see how specific sugars and amino acids might interact to form different Maillard reaction families of compounds. This research is really important to the developing cool climate sparkling wine industry because it has the potential to provide improved sparkling wine quality as well as innovation. And the reason that I'm interested in the wine industry to begin with is because I feel that it's a very collaborative space between basic research and applied research. I'd like to thank the American Wine Society Cleveland chapter and the Scholarship in Memory of Bill Davey for sponsoring and supporting my research. Thank you.
My name is Amanda Fleming, and I am a University of Arkansas master's student in the Food Science Department, focusing specifically on enology. My research focuses on enhancing wine and grape quality specifically in the state of Arkansas.
There are two parts to my research. The first is the creation and implementation of the Arkansas Quality Wine Program. In 2020, the University of Arkansas system received a grant to establish the AQW program. This program seeks to set quality and sensory standards for commercially made Arkansas wines. Additionally, the AQW program provides outreach to grape growers and winemakers, provides tastings to the public of Arkansas wines, and also has a yearly competition that showcases Arkansas wines made with at least 90% Arkansas-grown grapes.
The second part of my research focuses on the use of non-Saccharomyces yeast to enhance wine quality from Arkansas-grown grapes. The yeast used was Lactantia thermotolerans, which has the unique ability to ferment sugars into lactic acid. In 2020 and 2021, I harvested 2 different French-American hybrid red wine grapes, Chambourcin and Enchantment. For each grape variety, 4 fermentation treatments in duplicate were conducted using Saccharomyces cerevisiae with and without malolactic co-fermentation, and Lactantia thermotolerans with a sequential inoculation with Saccharomyces cerevisiae with and without malolactic co-fermentation. In wines treated with Lactantia thermotolerans, I observed significant increases in lactic acid and significant decreases in pH regardless of the malolactic regimen. Such results brought in options for achieving smoother, more complex wines due to higher lactic acid production, while achieving greater color and microbial stability due to lower pH values.
I want to thank the American Wine Society Educational Foundation and Banfi Wines for providing such a generous scholarship to help fund my education and my research. With my education, I look forward to aiding the grape and wine industry in growth and new discoveries, especially in the southern and eastern regions of the United States.
I'm Bernadette Gagne. I'm a PhD candidate at Washington State University in the Department of Horticulture, and my research focuses on alternative strategies for the management of the northern root knot nematode in Washington wine grapes. So the northern root knot nematode is a soil-borne pest, and it causes these little root galls on the roots of wine grapes, and those galls restrict the flow of water and nutrients throughout the rest of the vine. Above ground symptoms look like overall vine decline. So you're going to see reduced canopy, you're going to see lower fruit yield, you're going to see lower fruit quality, and just overall your plant production is going to be reduced. So my research focuses on trying to replace some of those traditional chemical management strategies with plant-based alternatives. So I work with several different cover crops, some in a pre-plant fumigation replacement scenario and others in an actively growing vineyard. And what that would be is replacing chemicals called nematicides with plant-based alternatives for the management to reduce northern root knot nematode population densities in wine grape vineyards. I am also working with resistant and tolerant rootstocks. So this would be your traditional wine grapes like a Cab or Merlot, Chardonnay, grafted onto a rootstock variety that is resistant or more tolerant to nematode feeding. So you get the control under the ground and you don't see any of those symptoms above the canopy. I'm really passionate about my research because it incorporates sustainability and plants helping other plants. I want to extend my sincere gratitude to the American Wine Society Education Foundation, specifically the Carroll County chapter, for awarding me a scholarship in 2022. Thank you very much for your support, and I look forward to continuing my research.
Hi, my name is Alex Gunn, and I'm a current graduate student in biological sciences at Brock University, specializing in viticulture. I'm very honored to be selected as a recipient of the 2022 American Wine Society Educational Foundation Scholarship, and I express my sincere gratitude to the North Alabama chapter for their generous financial support. My thesis research is centered on the use of structural abscisic acid, or ABA analogs, to both characterize and improve grapevine yield stress tolerance. I have shown that synthetic analogs extend the response of traditional ABA-based plant growth regulators through dormancy release and improve the kinetics of deacclimation, resulting in a delay of in-field bud break. In the upcoming academic year, I will begin to work on identifying mechanisms through which analogs act by quantifying the level of ABA and its catabolites in grapevine buds throughout the dormant season. I will also be harvesting fruit from our experimental field trials in the fall to determine if the delay in bud break caused by ABA analog application has an impact on berry composition. My motivation to pursue graduate level education in viticulture stems from my interest in addressing complex challenges that underlie sustainable crop management. As an undergraduate student in enology and viticulture, I sought to broaden my understanding of agricultural resilience in a changing climate by completing a minor in environmental sustainability. Inserting my perspective on pertinent issues that face cool climate viticulture in these transdisciplinary subjects really allowed me to flourish. My current research lays the foundation for exploring potential avenues of agrochemical commercialization in developing novel solutions to protect our vineyards from freeze damage. I have curated a thesis in applied plant biology that integrates the fundamental pillars of sustainability in viticulture. I am truly energized to continue contributing to this research both in my current graduate work and throughout my career. Once again, I would like to truly thank AWSEF and the North Alabama chapter for investing in my education.
Hi, my name is Jared Rykan, and I'm a PhD student studying under Dr. Jose Ramon Urbez Torres and Dr. Miranda Hart at the University of British Columbia, Okanagan campus. My research focuses on Petri disease in young vineyards. Petri disease is primarily caused by the fungus Clymonella luminospora, causing vascular necrosis, stunted growth, and eventual death of the grapevine. Petri disease can result in economic hardship for grape growers. Planting a vineyard has high upfront costs, with growers seeing little to no return on their investment in the first few years, so losing plants early on can be devastating. Unfortunately, grape growers cannot always tell when they have infected grapevines, as they can remain asymptomatic for years. This means that grape growers may be unknowingly buying infected grapevines from nurseries, and then years later losing some of these grapevines to disease. It has been previously described that Petri disease fungi are commonly found in nursery material, but it's unknown how prevalent they are in nursery material imported into Canada. And so the first part of my research involves conducting a nursery survey to determine the health status of this nursery material that enters into Canada. But with the widespread nature of these fungi, if every plant that was infected died, we wouldn't have viticulture in North America. Plant stress has been correlated with Petri disease symptoms, so I'm investigating what effects plant stress has on pathogen growth inside the plant, and consequent disease progression in young grapevines both in controlled greenhouse conditions and in field conditions. My research will help gain a better understanding of how plant stressors affect disease development in young grapevines. A reduction in plant mortality in young grapevines will be economically beneficial for grape growers, particularly in young and emerging grape growing regions in North America. I would like to thank the Central Pennsylvania Region Scholarship in memory of Tom and Joe Chesworth chapter of the American Wine Society Educational Foundation for this scholarship. Thank you.
Hi everyone, my name is April Mahovlik and I am a proud recipient of the AWSEF Scholarship for 2022. I'm a master's student in conjunction with the University of British Columbia, Okanagan, and Agriculture and Agri-Food Canada. My thesis is based on the use of cluster thinning or crop thinning to help mitigate the negative impacts of grapevine leaf roll and grapevine red blotch virus. My research for the following year will focus on repeating a field trial in which I'm measuring vine health, fruit quality as well as viral load in infected and healthy vines to really understand whether or not cluster thinning is making a positive impact and mitigating some of the negative effects these viruses have. My passion for the wine industry was sparked from growing up in Okanagan wine country. I am a proud resident of Summerland, British Columbia, where I was born and raised and where I get to do my research. And I have about 7 years of experience in the service industry through restaurants, liquor stores, and most recently wineries, where I was able to really get my hands dirty, work in the vineyard through harvests, as well as tending the vines and really understanding the hard work that it takes to be a grape grower in North America. And my research was, I needed it to focus on something that was a real world tangible solution for growers so that they could help manage some of the pains they have in the vineyard. I once again want to say thank you so much for the scholarship from the American Wine Society Education Foundation, and most specifically for the chapter that was responsible for funding my award. This goes a long way to funding my education, and I am very grateful. Thanks very much, and cheers!
Hi, my name is Meredith Persico, and I'm a doctoral candidate in the Department of Plant Science at Penn State University. First, I would like to thank the AWSEF Scholarship Committee and Board of Trustees for this award, which is funded by the Bucks County AWS Chapter Scholarship in memory of Kirby Andrews. My favorite part about studying grapevines and performing viticulture research is the opportunity to help solve challenges in grape production. My graduate research to date has focused on helping grape growers mitigate crop losses due to freeze damage here in our vine growing region. My first graduate research project looked at how we can delay grapevine budburst in the spring so that grapevines remain dormant for longer and therefore more protected against spring frost damage. I looked at how delaying budburst might potentially negatively affect fruit and wine quality due to shortening the growing season. Now I'm out here at our research vineyard at Penn State, getting ready for the second year of the experiment, where I'm investigating how the increased frequency and intensity of heat waves in late summer might negatively affect grapevine's ability to induce dormancy and cold acclimate in the fall and winter. I'm going to be investigating two different grapevine species. The first one you might be familiar with, Vitis vinifera, and looking at the cultivar Cabernet Franc in particular, which evolved in a relatively warm climate, and I'm comparing that to Vitis riparia, which evolved in North America in a relatively cooler climate. And my hypothesis is that Vitis riparia, in the face of heat waves, would be better suited to continue reducing dormancy and cold acclimating than Vitis vinifera. I hope that my research will help inform grape breeding for improved cold tolerance of wine grapes, in addition to informing grape growers of how the increased frequency and intensity of heat waves in fall might have carryover effects into the fall and winter. Thank you again to the AWSEF Scholarship Committee, Board of Trustees, and the Bucks County